Hello, everyone. Welcome to our session today with Chris Morin. We are super excited to welcome you to our session where we'll be going over codes and what they mean for you in the HVAC ecosystem. So, just a quick introduction about Chris Morin before I hand it over to him. Chris Morin is a sales leader at Mitsubishi, a former service manager, and an incredible HVAC educator and founder of HVAC Pro Blog. Most importantly to us at Conduit, he's one of our fearless advisors and HVAC experts. And today we'll be talking about an important topic of the intersection of codes and design. And I'm excited for you all to learn more. So without further ado, over to you, Chris.
Awesome. Thank you so much, Shelby. I every time you do an introduction, it gets better and better. So I don't know if I smiled too much, but I really appreciate the kind introduction. So welcome. I'm actually in my home office today in Upton, Massachusetts. And keep in mind, I know most of you guys are scattered around the country. Some of the stuff I might talk about, obviously, I have a focus locally, but it does pertain across the country, right? So I'm going to ask you guys, and just to make sure everybody's chat works and stuff like that, if you have questions, definitely put them in the chat. Shelby can either stop me or we'll get through them at the end. But in the chat, I want to know, does anybody here already do their own load calculations? Or maybe you might hire out or rely on your distributor or another company to do them for you. And this is something I always ask at the beginning of my in-person seminars, because I like to have an idea on the level of where we're starting with, right? And one time I asked this and I had an interesting response. And that's the reason for the picture here. It's a little odd, I'm sure. But the response I got was, Chris, why would I do my own load calcs? You know, it's almost like wetting yourself in a dark suit. He said that, sure, you get a warm feeling, but will anyone even notice? And what I'm actually telling you today is people are starting to notice if you're doing load calculations or not. At the very least, homeowners are getting more educated. Building inspectors are actually starting to enforce the code across the country. And they're starting to get educated and do it more uniformly, right? And this is kind of what's in it for you today. I know everybody's busy. It's getting warm across the country. You're probably sacrificing doing a sales call or an extended lunch right now on a Friday. So I really want to make sure your time is best spent. And I want you to understand that people are noticing. All right. And that's because the International Residential Code actually calls out Manual J and the requirements. So when you pull a permit, and this permit name is different across the country, like here in Massachusetts, we have a building permit when you do any whole home heating or cooling equipment. It could be a mechanical permit. It could be like a building permit that pertains to Title 24. It's slightly different, but it all comes back to the International Residential Code or something that's more stringent than that, that's local. And in section 1401, which is actually 1401.3, equipment and appliance sizing, and I'm not one to read slides, but since this is code, I'm going to make sure we get this right. Heating and cooling equipment shall be sized in accordance with ACCA Manual S, that's equipment selection, right? Or other approved methodologies based on building loads calculated in accordance with ACCA Manual J or other approved heating and cooling methodologies. Now, unfortunately, the approved methodologies is for the building inspector to approve. It's not what we say works. So there's no, 2 or 3 section boiler for those in the Northeast when you stand across from the house. Or you've ever seen Manual E, the joke when you cut out the size homes and you hold the sheet up from the curb on the other side of the street. It's unfortunately just as laughable as square feet per ton. And I think everybody on the call, including myself, has probably used some version of a rule of thumb in the past, which is not ACCA Manual J. Certainly not version 8 either. That rule of thumb probably died decades ago when it pertained to an old construction type on one house on a certain street in a certain town. If you're doing ACCA Manual J version 8, it's pretty extensive and there's a lot to it. All right. So when you pull a permit to either install a new or replacement system, they're going to be looking, the building inspector is going to be looking for a Manual J version 8 ACCA approved software report, right? If you're doing a new system, you have to do a room by room load calculation. If you're doing a replacement, would check with your building inspector, but most likely a block load would be fine. Then you actually have to use manual S to select the right size piece of equipment. Manual S will tell you how small and how large the system can be based on the load calc. And then if you're doing a ducted system, you need to do manual D as well, right? So this is a process, and these are residential design manuals, and they're actually manuals, right? I always get a smile. This is my daughter. She was right around 1 year old. She's now 14. So, but I snapped a picture, and that was my old copy of Manual J version 8. There's been revisions since. But what I want you guys to know is all of the calculations in the software is based on an actual manual. That's why it's called Manual J, right? There's not many pictures, and it's not a front to back read. There's a lot of tables, and there's a lot of stuff, examples in there. So if you ever do actually get a physical copy, and if you want to learn more, make sure you start with the appendices. Read the appendices first. That's the appendixes in the back. And then when you go through the examples, those examples will make a lot more sense at that point. If you don't read the appendices, it's like, it's not a book, right? It's a manual for a reason, all right? And now keep in mind too, this is the residential process, okay? You'll notice, I'm assuming everybody on the call here has the idea of system concept, and that would be, do we use a boiler or a furnace or a heat pump or an air conditioner? How are we applying it to the house, right? So that's actually selecting equipment based on comfort, okay? Then we do Manual J. So I always like to say, if you're doing HVAC sales, Manual J is the first part of the system design process. Now keep in mind, if you're doing commercial sales, Manual N is the commercial version of that. So I'm concentrating on the Manual J column here. And you'll notice there's a manual for system zoning as Manual ZR. Distributions, Manual T. That's how you select terminals, right? Or how you get the airflow from A to Z, right? Equipment selections S. Once you select the equipment, then you can design the ductwork. And then, of course, once it's installed, you should adjust, test, and balance the system. That's kind of the full process here, okay? So we're concentrating on that first step today, which is the first piece of proper system design, ACCA Manual J version 8. Now, if you're doing any sort of abridged version, that's actually equivalent to Manual J version 7 or earlier. Manual J version 8 software has this icon in the middle here. It says powered by Manual J. And all of the software providers on the screen, including Conduit, who's hosting today's class, thanks to Shelby, is eligible to use this on their reports, all right? And a building inspector should be looking for this icon on the report to make sure that it's approved by ACCA, not based on ACCA. There's two different things here. You can have any calculation. I could put together an Excel spreadsheet, which I have in the past. It's based on ACCA Manual J. It's not approved by ACCA Manual J. It's not powered by ACCA, all right? And if you ever want to find out if the software that you're using is ACCA approved, go to ACCA.org and click on standards and then go to software, and you'll see a list of every software that's approved with links to them, including Conduit now, right? So you'll notice as I go through the rest of the presentation, I'm going to use some reports out of Conduit that I've actually generated myself for my house, and some details on why Conduit actually is a great retrofit software if you're doing a lot of retrofit homes, okay? All right. So a lot of times when you go to pull a permit, you're going to have to complete what's called a residential plans examiner form. And that examiner form is actually developed by ACCA as kind of a overview of all of the system design manuals and all the details needed for the building inspector to actually show that you did the work, right? So everything on this overview form matches Manual J, Manual S, Manual D, right? So you'll see up in the top right, I just blew it up here a little bit larger for you. You should be providing Manual J1 form and any supporting worksheets, right? If you're doing Manual J abridged, because they allow it, which most building inspectors will not, you would attach that instead. OEM performance data is required to prove Manual S, your Manual D friction rate worksheet, and then, of course, a sketch of the distribution system is required for Manual D for code purposes. We're focusing on J1 right now, all right? So let me just tell you, I've worked a lot locally with contractors and building inspectors. I've had the privilege of teaching building inspectors this process, right? So I know the building inspector in Northborough, Massachusetts fairly well, and I reached out to him about accuracy of load calculations and code compliance. And boy, was he happy to talk to me. So he wasn't blaming me, fortunately, but he's saying that 85% of new construction load calculations, the applications fail because the load calculation isn't accurate. All right. And if the load calculation isn't accurate, the rest of the process doesn't work, including getting a HERS index score when you go to rate the system, right? When you go to rate the building. And that's what's required on a new construction building in order to pass code, in order to get occupancy. Okay. So what is on the home energy rating certificate should match the details in the manual J load calculation, right? And then that should match what's sized in manual S. What he's found is a lot of the people that are doing the load calculations themselves got the training and they actually are able to fix it, the details, or the ones that are passing are the ones that people are doing themselves. A lot of the subcontracted calculations are the ones that are inaccurate because they don't have all the details, and a lot of times they have to make assumptions, and they're actually making extremely conservative assumptions when new construction buildings are so tight and the insulation is so high, right? People are not selecting the correct information, and then these pieces don't match. He actually recommends, if you do fail, to try to get a one-on-one meeting with the building inspector, right? They want to help. It's not their job to deny, even though it feels that way as an HVAC contractor, like they're just looking for something to fail. They want to pass it, but if the things obviously don't match, they can't, right? They're there to protect the consumer in their town. So really important. He's saying get training and do calculations yourself. That's the most likely way you're going to be able to get the load calc to pass the first time, or quickly fix the things that are inaccurate to get to pass the second time. All right. So that's one case study. We have a couple more to talk about as we go. I promise it pertains to what I'm teaching. So actually, this is a picture of my house. When I bought my house almost 10 years ago, my wife said she thought it was because it was red, white, and blue. And I laughed. And I said, no, it's because there's one of everything in Manual J in my house. And it's going to make a great thing. I didn't say that. Imagine if it was, though. I just realized afterwards when I did these things, I'm like, I need a picture of this. And I had one downstairs, right? So I'm going to use my house as an example and just walk you through what the building inspector is looking for when you provide that information and what he has access to or she has access to. So what they have access to is the property card, right? So they can actually look at the property card, which is public information, and you have access to the town assessor's website. Almost everybody is digital these days. You can actually go to the town assessor's website and download the property card and get a sketched floor plan like this on the right-hand side of my house. And you can see what's first floor, second floor, third floor, right? And basement, of course. So I'm pretty fortunate. It's an old house. It's beautiful from afar, right? We like to say far from beautiful. It needs a lot of work. Actually, it's built in 1880. If it's been sold in the last 10 to 15 years and you Google an address, sometimes right on like realtor.com or Zillow or some of these websites, there's an actual floor plan, including like where the windows are. It's awesome. It saves you so much time in measuring if you have a software that doesn't do this for you. All right. In that case, I just have to print this off and just actually confirm measurements and say what the windows are and those window sizes, right? It's pretty easy when you're doing this. But what the building inspector is looking for is when your report, your Manual J1 form, when you have square footage, it's within like 10% of what the town assessor's site says. And if it's not, maybe there's an unpermitted structure or something that was finished that wasn't permitted, right? So you got to be very careful there. But if it's within like 10%, he's going to pass it, right? And that they face the correct directions. Then they're looking at everybody's favorite outdoor design conditions. So if you're along the coast or in the majority of the United States, you're going to be using Table 1A design conditions. If you're in a microclimate like Arizona, some of California, Hawaii, Nevada, then you're going to be using Table 1B. The design conditions are much different in really dry or very humid climates, okay? So I'm going to concentrate on table 1A and just show you some examples here on why we have these design conditions and why the building inspector is ensuring this, okay? So I am one of those people that like to explain why, not just to contractors, but also when I was in the home to a homeowner. It's really important that when I say, guess what, we have to design to 75 degrees and 50% relative humidity, you can't keep it at 68 in your house, that they understand why, all right? And there's probably associating comfort in 68 to a dry bulb temperature and a system that might be oversized, or it's 100% capacity. It doesn't ramp down to provide comfort. So they're used to turning that thermostat down. That's one of the reasons. The other reason is they probably have never really experienced 50% relative humidity because of that. So they don't understand what 75 and 50% relative humidity feels like. Keep in mind, and this is not a psychrometric class, but I want to make sure you guys understand why, right? So for cooling, 75 and 50% relative humidity is not just in the International Energy Conservation Code and the residential code as your design conditions, which is why the building inspector is looking for it, but it also falls into the middle of the comfort zone on the psychrometric chart. What this means is if it's really hot outside and the system's running all the time and it's above your outdoor design conditions, you can still feel comfortable inside, because even though it's not changing the sensible temperature down close to 75, it's going to run so much, it's going to keep removing moisture, and it might be 45% relative humidity and 78 degrees in your house when it's 110 outside, right? Or the opposite, which is the majority of the year, when it's, let's say, a little cooler than your design conditions, which we sized to, right? And it's humid. So let's say like late May in the Northeast. In that instance, because it's, let's say, 78 degrees outside, but it's 70% relative humidity, it's not comfortable, and I turn my air conditioning on. And when I do that, if I don't have some room for drift, it's not going to run long enough in order to remove moisture. So let's say we have to cool to 73 or 72 in order to get to 50% relative humidity. So that middle of the psychrometric zone for comfort for summer is why those design conditions. Same thing in heating. So if you have let's say a gas furnace in the northern part of the country, there's a lot of gas and oil furnaces. We always understand that if it's really cold out, the best way to feel more comfortable is not putting in an oversized furnace. It's actually to put a humidifier on that furnace, a whole home humidifier. When we add humidity, we feel more comfortable at a colder temperature. And the same thing happens in summertime. We feel more comfortable at a lower humidity when we remove moisture. So sometimes on an oversized air conditioning system, the right answer is maybe putting in a whole home dehumidifier. And what you're going to find is when we start selecting equipment and the revisions to Manual S, it's going to be a big part in selecting heat pumps, removing all that moisture in the home with a device that's separate in those types of climates. All right. So same thing here, middle of the comfort zone. They do allow you to have slight differences in heating design temps. They give you a plus or minus 2. They say 70 degrees plus 2. So the max heating indoor design temperature is 72. You can go as low as 68 if you wanted to. I don't know why you would design to a lower heating temperature, but you could. Okay. This provides room for drift. But I always like to say, what happens if a customer wants to still cool to 68? Well, guess what? 67 degrees on the typical refrigerant system. You're talking 410A, A2L refrigerants that are coming out. At 67 or less on a ducted system, the coil starts to freeze because we need a temperature difference across that coil in order to cool the air. Now the temperature difference the coil gets so low temperature-wise that moisture freezes, okay? So that's number one, mechanical issues. Number two is that cold air, if it's moving on the inside of ductwork, it's probably not going to be a problem. The problem actually happens on the outside of the duct system because that temperature air is so cold and it's running so long to try to cool down to that temperature that now the ductwork and any devices attached to it get so cold they get below the dew point of the air, let's say in your attic or your basement. And I like to equate it as like taking a can of soda or a glass of water out of the fridge. If you can imagine, the temperature of that glass is colder, and now it's below the dew point of the air, so we get all that moisture on the outside of that can or that glass. And you end up with water problems, moisture problems, cold, dark place, it turned into the M word. So highly recommend stay at your design conditions. Let the system, especially a variable speed system, run and cool the house normally, not big temperature swings and try to cool it really fast or heat it really fast. All right. So a little case study here. This is he might even be on the line. I've been working with Tony Manier as a Patreon member of mine for years. Tony actually works for a company, Wilson Brothers, up in central Massachusetts. And he's had really good success selling using Manual J as the first piece of the design process in the home on his first sales call, right? But when he does this, after he does a load calculation, he talks about the dangers of oversizing a system. Because if that homeowner has had somebody out there before, what he finds a lot of time is they're just sizing the system, the replacement system, based on what's there or some rule of thumb. So he educates the homeowner about, if I oversize or undersize the system, these are your problems. And what he finds is it's never about price, okay? On the right customer, the customer for Wilson Brothers, it's never about price. In fact, he told me this story about a job he just sold where he was $10,000 more than his competitor. And when the customer asked him about it, he went through this process. And what he found was they were just removing their old oil hydro air system and replacing with air source heat pumps. And the competition was just sizing the system based on the same capacity of what's there, but not necessarily even at the right temperature, the manual S calculation after you do J, right? They were just doing nominal size. So not only was the competitor's system going to be too small because it didn't perform at our design conditions here in the Northeast, but he was also $10,000 more, right? So after he showed them what he really needed for size in that house, he then used what's called NEEP, it's Northeast Energy Efficiency Partnership capacity ratings. So it's a third-party rating that's provided that's close to his design condition at 5 degrees to show them that, yes, it's smaller than what my competitor is offering, but I can show you that it's going to work and it's going to heat your home. All right. And this is a quote right from Tony, but basically only training, and please forgive me, my monitor is a little messed up here. Only training and studying and constantly learning gives him the confidence to say that if you want an 80,000 BTU furnace, you'll have to choose from one of the other 4 companies that were out here, right? But if you want a perfectly designed solution, you have to choose me. And he wins a lot of projects this way by educating the homeowner, doing a load calculation on the first call, and presenting an offer of a system that's sized correctly, not coming back afterwards, not emailing a quote, not, creating distrust with the homeowner, because the homeowner really wants to know what it's going to cost, not only because of price, but they need to sign something in order to get the project moving, right? Tony does a great job at that. All right. So I'll stop talking all these great things about Tony. I'll keep moving on. Another thing that that the building inspector is going to be looking at is glass. And that's because the glass or the fenestration is one of the things that impacts the cooling gain the most. So when you're sizing an air conditioner or a heat pump, this is a huge part of getting the calculation right. And what they're going to verify is that you put the right framing material in, you identified the right glass type, and you have the right U value. Now, on a new construction job, an NFRC sticker or that NFRC information is available to you, and you can just go to the nfrc.org website and type the number in and get all that info. If not, you're going to have to identify all these items, and the software will actually identify the correct U value for you as long as you get it correct. And make sure you're measuring the glass in feet, not inches. When it goes into your software, it's measured in feet. What's nice, actually, and I'll talk about it right at the end, but Conduit measures the glass for you, and it's very accurate. And actually, because I rounded, it created a bigger disparity with other software that I was using. I got a more accurate calculation by using stuff like LiDAR, right? All right. The next thing that we find that a lot of people don't get right locally and across the country is internal gains. And I think this is a spot where they get really concerned. I'm going to need a lot of people because these people like to entertain or something like that. I happen to have a fairly large home. It's an old chopped up house. I have 4 bedrooms. So the number of people actually in my home, it's not always number of bedrooms plus one because the 2 in the master bedroom, right? That's the total number of people that should be put in your load calculation. So a building inspector is going to look at bedrooms in the home and make sure the total number of people is bedrooms plus one. Okay, very cut and dry. Now, if you have full-time occupants, like I actually, until my father-in-law passed away, my in-laws lived with me, and we turned another room that wasn't a bedroom into one. Now, that full-time guest that we turn that in, we can actually provide that information to the building inspector. They should approve it in that instance. A lot of times people will put too many people in the home because they say, well, there could be a person in the office, there could be a person in the bedroom, there could be a person in the kitchen. And then when you add them all up, it's too many. Okay. What you want to do is put them in the rooms of where they're going to be during peak demand. So let's say 4 or 5 p.m. in the afternoon in the summertime, because then we can accommodate the airflow needed in that room for the people occupying it. Okay. So people go into that, and it's going to be the number of bedrooms plus one is your total. Where a lot of people actually miss on the low side is block load amounts for appliances. Okay. So most people will put what's scenario number 1, which is just, 1200 BTUs per hour, but that's a refrigerator and a range. Okay. That's enough for the basic kitchen, not even for like today's kitchen. Even my 1880 kitchen, because it has modern appliances, has more than 1200 BTUs per hour for gains in there. What most people should use at least is scenario number 2. And you'll notice these block load amounts are in every software because this is what's built into Manual J and the tables, okay? So if you're using scenario number 2, that's 2400 BTUs. That's twice the amount because you're going to include a dishwasher and a washer and a vented dryer in that, right? So also included in there is a refrigerator, a range with a vented hood, and typical electronic equipment and lighting that's normally on at 4 or 5 p.m. It's not a stock list of all the lights in the house and everything's on, even though it feels that way. My daughter's 14. I'm sure everybody that has kids knows what I'm talking about. What's normally on at 4 or 5 p.m. Okay. A lot of people for newer construction homes and for larger homes actually should be using scenario number 3, which is 3,400 BTUs. Okay. 3,400 BTUs just accounts for an additional refrigerator. So 2 refrigerators. And that's because people will have like, a freezer in their basement or an additional refrigerator in an entertainment area. And it's actually going to keep adding heat to the space. So we have to accommodate for that. All right. So if they have 2 refrigerators and the typical list of dishwasher, a washer, and a vented dryer, keep in mind there's no additional calculation for an unvented dryer. Has to be vented. We can't just dump all that moisture into your basement or your first floor, wherever it's located, unless it's a heat pump dryer. Obviously, that recycles that heat. All right. And then normal electronic equipment and lighting. Now, if you have above normal, then there's actually adjustments for that too. Okay. I won't get into all those details in today's brief training, but if you're interested, you can either look in the scenarios for Manual J or, just go to my YouTube channel. There's got to be at least 10 videos on that. All right. Next one I want to talk about is ductwork. Okay. And this is big because in order to meet today's code, there's a specific insulation value and duct leakage requirement, right? And it's got to be tested and confirmed. So in the 2021 International Energy Conservation Code, which most states are either on 2018 or 2021 at this point, whether the ductwork is inside or outside the building envelope, then you have to insulate the supply and return to R8. Okay. Now, if the ductwork is inside the building envelope because insulation was put over it, then you just have to meet the assembly requirement. So like if you need R38 in an attic and you have R8 on the ductwork, it needs to be R30 above it in order to get R38, right? And there's many examples that you can run through in the 2021 IECC on that. I have some visuals on YouTube as well. Check it out. All right. So R8 insulation on the duct system, and it's got to be sealed really well. Okay. Really well actually means if the ductwork is not entirely within the building envelope and the air handler as well is not entirely within the building envelope, then it's at least notable. Notable when you set that on your Manual J version 8 software, means 3.3% of leakage, meaning the leakage divided by 100 square feet that the unit services. That's what the code is. The code is actually 4 CFM at 25 pascals per 100 square feet with the air handler. All right. Now, the code requires you do a rough-in test if you can, but you have to complete a post-construction test and pass that 4 CFM per 100 square feet. Here's a little thing, though. If everything is within the building envelope, which is why we're trying to get a lot of ductwork in the building, or we're not using ductwork at all, that's much easier, right? Then you can leak less than 8 CFM per 100 square feet that the unit services, so twice the leakage amount. But keep in mind, that setting is much different in your load calculation. So you're talking about notable on a system that has ductwork or air handlers outside the building envelope. But if everything's within, it's actually somewhere between average and partially. And that can impact the load initially a lot. Okay. So really important how that system is going to be sealed needs to equate to what actually happens. Otherwise, you can undersize or oversize your system drastically. If you're using something like AeroSeal or something that can get extreme leakage numbers, obviously, even sometimes less than 1.8%, then you would set that for extreme in your Manual J section. Okay. Let's move on to some software reports. So when you provide that J1 form, it looks like this. Notice that big circle in the top right that says powered by ACCA Manual J. That's what the building inspector is looking for first. Then they're going to verify the basics like outdoor design conditions. Notice I changed my outdoor design conditions for my house here. Oh, I should have blocked off all my information. Well, you have to do that in post, Shelby. But you can see I went from 7 degrees to 6 degrees in heating, 83 to 86 degrees in cooling for outdoor design conditions, because my closest weather station was actually the airport in Worcester, which is a much higher elevation than where I am in Upton, Massachusetts. Okay. So if I was to use the correct design conditions based on my elevation, the closest weather city data was Clinton. And the building inspectors in town know the design conditions you should be using. Then they're going to look at design conditions inside, make sure it matches code. They're going to take a look at square footage and see that you're within 10%. And then they're going to look at total heat loss and total heat gain with the sensible and latent split out separately. Okay. That's what's going on to that plan examiner's form that I showed you at the beginning of the training. Then they're going to look at the details. They want to make sure that the ceiling material is correct. Is there insulation in the ceiling, right? Is there insulation on the walls? Do the walls face the correct direction? Is there a lot of glass facing south? And is it actually that way at the house? If you have a ceiling U value that's actually greater than that's greater than 0.1. Remember, 0.1 is R10. It's the inverse of the R value. Then they're going to probably call you out on that, because R10 insulation in a Northeast climate is next to nothing. All right. So they're looking for something very obvious in the details, like skylights, but there's no skylights at the home, that sort of thing. Okay. And then all Manual J version 8 software will provide a fenestration load curve. And if that load curve actually goes up above 1.3, that average goes above that in this case, orange line, then you probably should look at zoning the home either with equipment or with ductwork dampers, right? All right. Next, they're going to take a look at the number of people. Remember, one person's just 230 BTUs per hour, so it's not a lot. Don't add too many into all these rooms because it adds up, okay? Make sure you're going to put them where they are at 4 or 5 p.m. And then they're going to see that the appliances are 3,400 BTUs. That's scenario number 3 or less. If they're above, you just have to provide details as to why. So let's say I have 2 ceiling fans on my on my first floor in my living room. And if I'm going to run that when it's during peak demand, there's an adjustment because there's motors within the space. It's actually 250 BTUs, I believe. So you would add 250 per motor in that space. You don't want to omit things that are going to be on during peak, right? That would be on top of the block load. Or I have, let's say, 6 or 7 can lights in my kitchen, and they're not LED, and they're throwing off a ton of heat. I'm obviously going to be cooking in the evening during peak demand. So I want to make sure I adjust for that lighting. Otherwise, when I turn the lights on, it's going to be unbearable in the kitchen because I didn't adjust for it. All right. And then they're going to take a look at duct loads. Make sure you have the right setting for insulation, for leakage. If you have duct work, there's actually duct loads, or if they're ductless, there's no duct loads, right? They're going to look at for the obvious here. So just kind of a little bit of a summary before I start wrapping this up. First off, don't manipulate outdoor design temperatures unless you absolutely have to, because you have to get it correct for your elevation. That's the only time you should be changing it. Manual J and actually Conduit will pull in your location weather city data from ASHRAE information. So that's the most accurate. Just make sure, like in my situation, it's the right elevation. Then make sure you take full credit for efficient construction features like shading over windows and, you know, actual shades in the office, right? However, when you do your site survey, if the house is actually being lived in, that's what you should be including in your calculation. Don't ignore window shading if it's not there, if no one's living there, right? Keep in mind, when somebody moves in and you can look through the window and see the neighbors, they're going to put shades up. If you don't know what it's going to be, then there's a standard in Manual J. It's medium blinds, half drawn at a 45-degree angle, right? And then, of course, don't apply any additional safety factor to the results. And this is a quote right from Hank Rakowski, who wrote Manual J. I was fortunate to be taught by him almost 15 years ago now. He said that research studies indicate that Manual J version 8 procedure provides an adequate safety factor. In fact, it's 20% oversized if you do the most aggressive load calculation, because they have to stop the decimal point somewhere. You can't just have them go on forever. And when you round every ceiling and wall and door and floor and window, that stuff adds up. And it's already 20% bigger. And then when you select equipment, the system can be bigger on top of that too. All right. So there's no need to manipulate temperatures or ignore window shading and put, little insulation in the attic when it's much higher. Do what's actually there. Do an aggressive load calculation, and you're going to pass for code, right? And you'll be able to select the right size piece of equipment and sleep at night, knowing that you did the right thing. In fact, this is Rick Picard. Anybody working locally probably knows Rick. He's very well known in our industry in Massachusetts, extremely successful salesperson over at Rodenheiser Home Services. I've worked with Rick now probably 10 or so years. He actually came to me initially because he was having problems with permits with a building inspector. And we sat down with the building inspector and came to a clear understanding of what he was looking for in calculations. And Rick said it made him a much better salesperson and a much better designer, knowing what they're looking for and becoming more accurate because he went and got training to fix that. And what he found is the next step in selecting the right size piece of equipment after you do an accurate load calculation gives you enough leeway to be comfortable with Manual S and providing comfort to that homeowner. And really what he's found is he's able to capitalize on like Mass Save whole home rebates, or, he's working at other states as well, other rebate programs, because, they're looking to provide a whole home incentive to switch from a fossil fuel to an air source heat pump. And that requirement means he has to be able to size the system to 90% of the heat loss. It's not just sizing it based on the oversized furnace that was there. And he's got to do a room by room Manual J load calculation, right? And really it's required not just to get the rebate, but in order to switch the fuel source. Because if not, no wonders the system isn't comfortable when it's really cold or really hot outside. All right. What he's found by including ACCA Manual J in his process, getting the training and always offering these rebates, he's actually increased his average ticket and increased his close rate. And the company has actually shifted to offer 100% satisfaction guarantee. And Rick tells me he's never actually had to offer it to somebody. Of course, they have other salesmen who have. Rick follows the process, and every system that he sells, it gets installed correctly and it's comfortable, right? So that's really what we should be looking for here. If you're in HVAC sales or you're a HERS rater, and you're trying to understand the process and what the impact is to the HVAC contractor, this is a great example, a great case study as to why you should do it right and how it can be profitable for you. All right. So if there was a lot of stuff and I was going very fast because I am from the Northeast, I talk kind of quick. I actually put together a very short how to pass load calc requirements for a permit ebook. It's like 8 pages. It's really short. There's a QR code right here. If you scan this QR code, you can put in your email, say yes, it'll send you over that ebook. If it doesn't, you can find me on LinkedIn. You can find me through Shelby here over at Conduit. More than happy to make sure we follow up to get that information to everybody that attended or is watching this afterwards. I actually talked so fast, Shelby. I finished 5 minutes earlier than I wanted to, without any sort of crazy issues like we had before we started. So we had some little technical problems before we started here, and I think it went pretty well. I didn't.
It did.
Okay.
Yes, we had quite a few people dialed in on LinkedIn and YouTube, but no questions. So
no questions. Oh my gosh.
With that, I want to thank you, Chris, so much for
Yeah.
taking the time to share your insights today. We will be sharing this out, putting it onto our website. So if anyone wants to watch it again, which I certainly do, or watch any of the clips, we'll be releasing those as well. So thank you, Chris, for joining us today. And thank you, everybody else in the audience, for joining us as well.